Hello, Jeremy here. Today we will go over the text hyper program I wrote to do the text display in this video series. It is very basic right now and will be improved during this series, and it will be done live. Since I've already written the basic program, I'm just going to go over it, but from here on, any additions will be recorded for you to see, warts and all. However, we must first deal with lists. So to introduce lists, which is a new data type, I'm going to open the REPL. So go ahead and get that up. All right, here's the command line. Go into Python. All right, so before I showed you numbers, so something like x equals 42, and that gave you a number. And then you can do things with the number, like do addition, subtraction, everything you can think of doing with the number. So with a list, we can have a list of numbers. Clever, eh? 3. That gives you a list of numbers. Now, what we can do is we can access an individual number from the list we want, numbers of 0. So this is saying access the index 0 of the list. And little square brackets indicate indexing into a list. This is actually pretty common in other languages. It's not just Python that uses this notation. So the 0 index refers to the first element. So index 0 is here, index 1, index 2, index 3, which is outside the list. What you'll see is that. I'll show you. So numbers of the 0 index, numbers of the 1 index, numbers of the 2 index, and numbers of the 3 index, which is an error. So this is the index error saying that we tried to access an element here on in the list, which doesn't exist. And it's telling you list index out of range. So it's outside of the range of the list, which is these elements. The reason for 0 is actually very subtle mathematically and kind of beyond the scope of this video. So I've seen an explanation as to why it's 0 from a kind of a mathematical perspective, but also just from programming a lot. It also seems to be related to addressing. So I'm going to essentially say there is a reason, but it's also highly traditional for this to be 0. So I'm not quite sure if the reasons why lots of languages use 0-based indexes are for the mathematical reason or just for the traditional reason. So that's that. Okay, so indexes are neat and all, but that's not the major reason why you use a list. You usually use a list so you can loop over the list and do the same operations on each element of the list. So the way you do that in Python is with a for loop. For number in numbers So this says loop over the list of numbers and call each element in the list number. Print number. So this loops through each element in the list and prints out the number. So for each number in numbers, print the number. That's how you can read it out. You can also, to do this, I'm hitting up and down. Number times 2. And that multiplies each number. Okay. And then finally, you can also do this multiple lines. So again, this indentation is denoting a block, and blocks are sequences of instructions. So you can have multiple instructions that belong to the thing that's dedented. So the for loop here is everything underneath and indented under the for loop belongs to the for loop. So we'll say number equals 2 times the number plus 1. And you want to print out the number. And that gives you the information. Another thing we can do is we can sum the information. So we want to like have a sum. We set the sum to 0, and then go through each number. Sum equals sum plus number. There we go. And now sum should have the sum of the numbers, which is true. I might have broke Python's internal function. Yeah, I think I did. Yep. So Python has an internal function called sum. Okay. So if you want to delete a variable, you can use del and then the variable name, and that'll delete it. So I deleted sum, which was local, and then I was able to get to the built-in function. The reason why I wanted the built-in function is actually does this for you. You can do sum of numbers. I'll show you that at 6. So this is a built-in function that just did exactly what we did with that for loop. Okay, so that's the lists and doing things with lists. So the main thing with lists is you want to use a for loop on a list and do the same thing over and over again with the elements of that list. So with that in mind, we will take a look at the program. Let's go here. Okay, so we need to do, okay, so import Pygame. So import is a statement which imports a module into your current module. So when you run a program on the command line, you create a module called main, and whatever code in the command line is part of that module. Now, it's possible to pull in other modules with imports. A module is a place where other code can live that's in its own space called a namespace. It's aptly named because it's a extra area that has its own place to store different names, hence namespace. So what's in these modules is code that typically other people have written, like libraries and stuff, that you can reuse and share. But it also allows you to organize the code better, and it allows that code to be shared as well. So here in this case, we're importing Pygame. Pygame is a third-party module that someone else or another team of people have wrote or collaborated on, and it allows you to do game functionality in Python. So that's what I'm going to be using it for. And this text typer program, as you've seen, opens up a window, has a black background, and will type green text. And I can advance it with the enter key. So whenever I hit enter, it goes to the next line. So the issue is normally this module Pygame is not on your machine, so you need to get it installed on your machine. And Python has a handy-dandy tool to help you pull modules onto your machine. It's called pip. So I'm going to go here and show you pip. And this is running pip. These are the flags and commands we can do with pip. So the thing that you want to do is do this pip install. This says install a module, Pygame. And you can see that it didn't do anything because I already have it installed. Requirement already satisfied. That's what that means. And it's also telling me I have an old version of pip and I should upgrade. A very old version of pip. Alright, so another thing you can do with pip is you can do pip search for game. And that'll show you all the modules, also called packages, that have game in their name. Unique game, Dino game, Life game. You can see there's a bunch of modules or packages that have that. So that if you wanted to search, you can, like, I want to search for music related modules. Okay, I found it. Music players and playlists and Google Play. So this is a way to search for a module. You could also use Google if you wanted to. Or search any search engine you want. Alright, so that's how you would install Pygame. I'm going to assume at this point that you have Pygame installed, so you can follow along with the episode. Okay, so this imports Pygame. This line is a special form of import. It says, from the Pygame module, we want to import the name surface and rect. Surface is an object that represents the drawing surface that you're going to be drawing on. So it represents the window that you see that has the black background. It will have the text on it. So that's a surface, which could have other surfaces within it in a nested hierarchical form. Rect I will talk about rect when we actually see a rect. Probably don't even need to import it here, but it'll most likely be useful later. Okay, so here is a list. Episode 0 lines is a list. It is a list of lines for episode 0. You see, this is the script that I read for video 0. I also noticed that I kept a tradition of 0 when I started the series. So this is a list of strings, and they're comma separated. Each one is going to print out when I hit enter. And this line is how I get the blank line. So you can see the separation. So this is the lines for episode 0. These are the lines for episode 1. These are the lines for episode 2. Okay. This is the main function, which I'll skip over for briefly and come back to. Alright, so this is the main entry point into the code. This if statement is a little bit strange looking right now. So what this means is this variable here is a special Python variable which is set by Python, and it is set to the string underscore underscore main underscore underscore when it is executed in the command line. So this is saying that if this module is the main module, essentially if it's been ran from the command line, and if it has called the main function with episode 2 lines. So I did this so I could go episode 0 lines, or episode 1 lines, or episode 2 lines. So that way I could do this regardless of what episode we're on. This is the cool thing about functions. It allows you to do the same thing but on a different set of data. Okay, now we go up here. I have to look up a main function. So as we saw when we called it, we passed in the lines that we wanted to print or do the text paper functionality on. So this is what we do when we do that. We do pygame dot init. So this dot you haven't seen before. What it means is it's accessing members within either a module or an object. So in this case, it's the pygame module. I will briefly talk about objects. Objects are collections of functions and data which allow you to organize them and put them in one coherent place. And I will go into objects in a later video, but that's just a brief primer on them. So the pygame module has this init function which initializes all the underlying code in the library for pygame. Pygame.font. So pygame module has a font module within it, and this is initializing the font module. This is a requirement, so init must not initialize the font module, so you have to initialize it separately. So pygame.display. Display is an object which corresponds to the display we see. So it's the black screen, and it has the caption and all that. So that caption sets the on the title bar the text it would show. OBS does not capture the title bar, so I cannot really show this to you, but when you actually do it on your screen, you should be able to see that it sets this up. Okay, so this is the line which actually gives us our surface, so we have access to it, and it sets up the display. So pygame.display access the display object, and then set the mode. So this is the resolution right here. Resolution. This notation, the syntax, is the syntax for a tuple. You can think of a tuple as a list. And this would work just as easily. I'll keep it like this, just so you can see that it is fine. So this is setting the resolution of the window. It is 1,280 pixels wide by 720 pixels tall. This is 720p. This is saying what properties the display has. This little bar is the OR, Boolean OR operator. I'll explain Boolean in another video, because it's going to come along with the explanation of binary, so it's going to be fairly intensive. So what this is saying is we want a surface that is double buffered, and it's going to be a hardware surface. A double buffered surface means that the video buffer has two buffers, buffer A and buffer B. When buffer A is displayed, when you actually write to the surface, it's actually writing to the buffer B, the non-display buffer. So you draw and write everything into that buffer that's not being displayed, and then when you want to display it, you swap the two buffers. So B becomes A and A becomes B. That way you don't see any flickering or any screen drawing going on, except when you want to show it. So we'll see that later on in the program. Hardware surface means that the surface is going to be in video memory on the video card, instead of drawing it in RAM and then moving the RAM into video card memory. Okay, so next is setup of running this. There's a main loop of the program, which we always say is running. We set up as running. In the loop, when we get user input, we can set this default to cause it to stop listening. We get Pygame, so we say from the Pygame module, there is a time module. We want to create a new clock object. So this was used for synchronization, which we'll see later. And we store it in the clock variable. We create a font object. So pygame.font is the module. Within that module, we have a system font object. This says I want the terminal system font. So this is a monospaced font at 40 pixels. So this is giving us our font object. We could switch this to like Arial or Helvetica or whatever your system fonts are, Courier. So that's how you would select a font. And that object is stored here. The line index tells us where we are in the list. So this is index 0, index 1, index 2, and so on. So we start at index 0. Line height is where you are on the screen when you're drawing the pixels. So we're starting at an offset of 5. So let's just go to that in the text typer. Do I have that up anymore? Yes, I do. Okay. So you can see here that it's 5 pixels down from the top. And it's actually 5 pixels in from the left edge. So when we're doing pixel coordinates on a computer, it's a bit strange. You would expect the origin from math, you'd expect it at the center of the screen. And then as you go in the X direction, you go to the right. And as you go in the Y direction, you go up towards the top. But that's not how it works. The origin is in the upper left-hand corner of the screen. X goes to the right, kind of how you would expect it to. However, Y goes down, so it's the opposite of what you would expect from mathematics. So if you're used to math, the coordinate system is quite a bit different. So that's an explanation of the coordinate system. Let's go ahead and go back to the code. All right, and new text says if we have any new text to draw, because this is going to be going at 30 frames per second, it's going to be looking for when I hit enter, and when I hit enter, it wants to draw a new line. So we need to say when we are going to be drawing new text or not. And that's what this controls. Okay, so now we actually come into the loop body. So while it's running, so that was true when we set up, we're going to draw. So here this new text will draw out. I'm going to go over this kind of at the high level and then explain it in more detail. Frame sync, this synchronizes the loop and makes sure that it runs at 30 frames a second. This number determines how many frames per second the loop will run at. So if we get here and we need to delay for some time to get to 30 frames per second, this will wait. So at this point in the code, after this point in the code, we are at 30 frames per second. Then we get input. This pulls all of the mouse events and keyboard events or any kind of input from the user. And then we update the state of the program. This is where we would say, okay, I want to stop running the the code. Or if I hit enter, I would advance the line index to the next line and say I have new text to draw. Or I do nothing because I got no input and we just wait around until we get input. So we get that, and we get to the bottom, we're still running. We get here, still running. Okay, so let's go into more detail. Now, let's assume that we actually have something to draw. So we have new text to draw. So the first line is telling going, hey font, I want you to render out some text. So given this font and some text I want you to render out, draw me text so I can display to the screen. So here is the text we're going to draw. So the lines that we passed in, which are these lines, and given the line index is 0, it is this element. So this string will be drawn or rendered. So it renders that line. This argument is for anti-aliasing, so it's true. And this is the color of the text. So this is green. RGB, red, green, blue. RGB. It's a standard color order scheme for computers. Again, you see tuples. So this is saying render that first line anti-alias in green. And what it'll do is it'll return a surface with the text rendered to it. So that way you can put, with this next line, you can put that text anywhere you want on the screen. So that's what we're doing here. We're putting the text that we rendered onto the screen in any location. So text screen.blit, this copies information from one surface to another surface. And so this is copying the text, so the text surface, so it has rendered a line on it, which is, well, this is actually episode 2, so it's just say hello Jeremy here, and then copy that information to the surface. So let's actually show this in program. I'm going to restart my program. Go ahead and show it. And it says, hello, Jeremy here. So that's exactly what we expected. And we go ahead and run through that. Okay, so this is the important part. This says, render the text at X coordinate 5, so that's going to be 5 pixels in from the left, and the line height down. So the line height was set to 5, so it's going to indent 5 pixels from the top inwards. And then we're going to update the line height. So this is special notation. This means the same thing as line height equals line height plus text get height. So this plus equals is equal to this. So it's an abbreviated way to type this. Whenever you want to add something to itself, that's how you would do it in Python. Actually, lots of languages have this syntax. It's pretty common. Okay, so what this is doing is it's saying that the text that we rendered, tell me how tall it was. So when I print it the next time around, I will have the correct location on the screen. So this is keeping track of where to print it on the screen. And then we say flip the buffers. So remember the double buffer? So we were drawing on the buffer that's not visible, and then we're saying flip the buffer. So flip the buffer that we were drawing that wasn't visible and make it visible. So this is where we actually show the work we've done. And then we say that we don't have any more new text. So it's false, so the next time this goes around, we won't do any updating of the display. Synchronize, get the keyboard events. Now we do special stuff. So it's possible that during this period of time where we've been drawing and we've been waiting around for it to synchronize, that the mouse and the keyboard have gotten multiple events. So this function gets all the events that have happened since the last time we've called this function. So we need to loop through all the events. So this is saying for each event in the events we got, print out the event just so we can see what the event is. And then is this event, so is the type variable in this event object is equal to a quit event. So Pygame has a variable already defined for the quit event. And you'll see that Pygame has lots of predefined variables that we can use. So it would go to quit event. This is usually if you click the X on the window to close it, this is usually what that is. We set running to false. So when we set running to false, when we come back to this loop, it will break out of this loop and hit pygame.quit, which kills the graphical window and causes the engine to slow down and quit. So this causes Pygame to quit. Okay. Otherwise, if the event type is equal to pygame.keyup. So Pygame on the keyboard, Pygame tracks kind of two events for key press. When you press a key, that is considered key down. And when you release the key, that is considered key up. So what I'm looking for is not the key down event, I'm looking for the key up. So they've released the key. And if they release, so if event.key equals key return, so this is predefined for the return key. So essentially, if they just released a turn key, the return key, we're going to say there's new text and advance the line index by 1. This conditional statement is making sure that we do not go past the number of lines, so we don't index past the number of lines. So here, index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7. So we don't index 8. So there are 1, 2, 3, 4, 5, 6, 7, 8 lines. Yeah, I could have, yeah. So there are 8 lines. So when you say, oh, I haven't shown len. Okay. Len on a list tells you how many elements there is in the list. So there are 8 elements in the list. And we subtract 1 from that to get 7. So that will correct for the fact that indexes start at 0. And we want to know if the line index is less than 7. If it's less than 7, we can print out a new text line and advance the line index so we go to the next line. So this is the logic to go to the next line and allow the program to draw the next line. Here we have, if we are releasing the escape key, we set running to false. We release the Q key, we set running to false. And that causes the program to quit. So that is the explanation of how this program works. So what I'm going to do is, because I've noticed that this is a bit absurd. For every episode that I draw this kind of script for, I'm going to have all these variables with lists in them. What I want to do is I want to put each script in a file and then just tell the program what file I want it to use. So then it can start displaying what's in the file. So I want to modify the program to handle files and manipulate files, which will be perfect because I'll then be able to show you guys how file I/O works. So we can read from files. Writing will probably be a bit later, and we'll show you how to deal with the different lines, how to loop through the information. It'll be good. So look forward for that update, and I will see you later.